For all we know, the vibration produced by the earthquake is called the seismic waves. So for today, we need to identify the different types of seismic waves and explain how earthquake waves provide information about the interior of our Earth. So, as a review, also when it comes to the layers of the Earth, for all we know, that the core of the Earth somehow it has two layers. The inner core is somehow solid and solid metal, then the outer core is considerably a semi-solid. The reason why we can or we identify their structure is because of the earthquake. So during an earthquake, the energy release travels, penetrates, and passes through the Earth's interior in all directions. The field of knowledge that studies earthquakes and seismic waves is called seismology. Seismic wave is usually generated by a tectonic plate movement or earthquakes when rocks within break, producing a tremendous amount of energy. It comes from the Greek word seismo, which means earthquake. Seismic waves are recorded in seismograph, and the motion of the ground can tell what type of seismic waves have transpired. So let's talk about the types of seismic waves. And the main types, or the two main types, are the body waves and the surface waves. So each of them characterized by its speed and direction, depending on what kind of materials they are traveling through. Let's start with the body waves. It originates from the focus and can travel through Earth's interior before the surface waves, which can only move along very near the Earth's surface. And the body waves do have different types also. One of that is the P waves, or known as the primary waves. It is considered as the fastest seismic waves, and it is the first waves detected by the seismograph. The primary waves can travel at greatest velocity. It can even penetrate gas, fluids, and solid rocks. It can travel as fast as 1.6 to 8 km per second. Compressional moves alternately pushing and pulling back the rocks to the direction the waves it travels. The second type of the body wave is known as a secondary waves. It is a transverse wave, also known as a shear waves, that follows the P waves. In secondary waves, this is the second one to arrive after the primary waves in the seismic recording station. It travels half the speed of the P waves, but still it's fast. More, it is considerably dangerous due to larger amplitude, causing the ground to rapidly split and move in different direction. In the secondary waves, it can even penetrate solid materials and stop at the liquid layer of the Earth. This led the seismologists to the conclusion that the outer core is liquid, like what I told you a while ago. Also known as shear, because when it hits the outer core, it disappears, and once they hit the inner core, they reappear. Instead of longitudinal, it moves perpendicular to the path of the wave. So it moves up and down, or the wave moves up and down. Then the second one is called the surface wave. The surface wave may last, or it is the last wave that arrives due to their lower frequency and lesser velocity compared to the body waves. The surface wave can cause more destruction because of long duration and larger amplitude of the waves. So waves that it is the kind of wave that people feel and generated when the focus is shallow. These are the different types of the surface wave. First, let's have the love wave or waves. It is proposed by Augustus Love. It moves on the ground horizontally, causing it to twist from side to side. The love wave propagates at the right angle and decreases with depth. It damages the foundation of the structures, whether that's a building or any kind of. The second is the Rayleigh waves. It is considered as lower down the L waves or the love waves. It has a lower velocity also and was proposed by Lord Rayleigh. It generated by large earthquakes moving the ground up and down, then side to side in the same direction that the wave is moving in rolling motion, like this. And lastly, what about the aftershocks? Shaking that follows the first earthquake is the aftershocks, smaller earthquakes that occur after the previous main shock or the initial earthquake. It usually happens along the same fault and caused by realignment of the two plates. In some instances, the aftershock has greater magnitude than the main shock. It that in that case, the original main shock is considered as the foreshock, and the foreshock or the aftershock is renamed as the main shock. There are times that aftershocks do not occur instantly right after the major quake. The longer the delay, the more difficult it is for the seismologist to distinguish between an aftershock and an entire new earthquake. So the aftershocks may tend to occur within the first hour after the large earthquake and may be repeated after an hour, which may last for a week and may continue over a period of months or even years and decades, depending on the strength of the main shock. So that's it for today. Thank you very much again, and thank you for watching and listening. Bye bye.